Good morning, my students. Chapter 1. The rest of Chapter 1 I explain today. The rest of Chapter 1, Ohm's Law. In the previous session, I explained the electric current intensity and the potential difference. Ohm's Law determines the relation between potential difference and electric current intensity. I said in the last time the potential difference is energy or work done to help current to flow. So the relation between V and I is directly proportional. Ohm's law, the current intensity in a conductor or in wire is directly proportional to the potential difference across the ends of the wire at constant temperature. To remove the proportional sign, I can put equal and constant. V equal constant I, this constant is called resistance. So Ohm's law, V equal I R. R constant, resistance. R, it is the opposition to the flow of electric current. Resistance of material or ohmic resistance R, it is the opposition to the flow of electric current. Each device in our houses has a resistance. The wire has a resistance. It's unit ohm. Or from Ohm's law, V equal I R, resistance can be defined from V and I. R equal V over I. Divide, I mean ratio, so the resistance can be defined by this way, is the ratio between potential difference of two terminals and current intensity passing through it, V over I. I say constant temperature in the definition of Ohm's law because the resistance is directly proportional to the temperature. We increase the temperature, the atom inside the wire move more, so the current find atoms in its way to opposite the flow of charges. So the resistance of the wire is increased. We have factors affecting resistance at constant temperature from this law, R equal rho E L over A. Resistance is directly proportional to the length of the wire and inversely proportional to area of the wire. And the resistance is directly proportional to the resistivity. Resistivity, I mean specific resistance for the material. Resistivity, it is the resistance calculate this resistance to the wire or to the material of the wire can be calculated by the free electrons in this wire. For example, a copper has more free electrons. So we can say the copper good conductor for electricity because the electricity free electrons moves in the wire. I mean conductivity of the wire is high, very high. So its resistivity rho E is very small. But aluminum, also metal, has free electrons. These free electrons less than free electrons in the copper. So conductivity of aluminum less than conductivity of the copper, and resistivity of aluminum more than resistivity of the copper. So resistivity, it is the specific resistance to the material. Now we can conclude the factors affecting resistance to 4 factors. Number 1, length of conductor. Resistance is directly proportional to the length of the conductor. 2, cross-sectional area. Resistance is inversely proportional to the area of the wire. Kind of material, I mean specific resistance of the material. Okay? At constant temperature, mention 3 factors only. But when remove this statement at constant temperature, when ask you to mention factors affecting resistance only, يبقى increase number 4, resistance is directly proportional to the temperature. Okay? Okay. Resistivity from the law R equal rho E L over A. So resistivity equal RA divide L. RA divide L. Define resistivity from this law. Resistance of wire, 1 meter long and 1 meter square cross-sectional area. Unit of resistivity, resistance ohm, area meter square, length meter. Meter cancel مع السكوير يبقى ohm meter. This is the unit of the resistivity. Electrical conductivity, it is the reciprocal of resistivity. I mean 1 over resistivity get electrical conductivity. Its unit ohm power negative 1, meter power negative 1. We can define electrical conductivity like reciprocal of resistance of wire 1 meter long and 1 meter square cross-sectional area. Okay? Factors affecting resistivity or conductivity, kind of material and temperature. When free electron increase, resistivity decrease and the conductivity increase. Temperature, when the temperature increase, the resistance increase. And the resistivity affected and the conductivity affected by temperature. Okay? When current of 2 ampere flow through a uniform resistor, the potential difference solve problems. When a current of 2 ampere follow through an unknown resistor, the potential difference across it will be 10 volt. Okay? I equal 2 ampere, potential difference equal 10 volt. Calculate the resistivity, calculate the resistivity and the electrical conductivity of the material of such resistor if it is length is 2 meter, and its cross-sectional area equal 0.1 centimeter power 2. You need resistivity in the law of resistance equal rho E L over A. So resistivity equal rho A divide L. RA divide L. Or resistance, I haven't resistance, but I have current and potential difference. From Ohm's law, resistance equal V over I. V10 over I2 equal 5 ohm. Substitute in this equation, resistance equal 5, area time area 0.1 time 10 of power negative 4 to change the centimeter square into meter square, divide length to meter, equal 2.5 times 10 of power negative 5 ohm meter. Conductivity 1 over this number over resistivity equal conductivity هتبقى 40,000 ohm negative 1 meter power negative 1. Okay? A wire of uniform cross-sectional is 140 centimeter long. This is length. It is cross-sectional area is 7 times 10 of power negative 4 centimeter square area, and the resistivity of the material, resistivity, calculate the resistance equal rho E L over A. Substitute R equal rho E اللي هي resistivity 5 times 10 of power negative 7 time length 140 centimeter يبقى turn to meter time 10 of power negative 2 divide الاريا 7 times 10 of power negative 4 times 10 of power negative 4 to 10 centimeter square into meter power 2 equal 10 ohm like this. Okay, when make ratio to this law R equal rho E L over A, R1 over R2 equal rho E1 over rho E2, L1 over L2 directly proportional, and area inversely proportional تبقى A2 over A1, or area equal by R square, area 2 تبقى R2, area 1 تبقى by R1 square, by cancel مع الباي يبقى R2 square over R1 square. يبقى this is law to solve problems talk about two resistors. When the problem talk about two resistors or two wires, I use this rule. Like this problem, a student made two resistors from the same material. Same material, I mean same resistivity. Resistivity cancel مع resistivity. The second is double the first in length. L second double L first. And its diameter is equal to the radius of the first. Diameter 2 equal radius first. Calculate the ratio of the second resistance to the first one. عايز السكند resistance to first one يعني هعمل reciprocal لللو. R2 to R1 resistivity same فكنسل each other. اللينس هتبقى L2 to L1 يبقى R2 to R1 equal L2 to L1 over L1 time area 1 اللي هي area 1 اللي عندي R1 R1 equal diameter 2 يعني equal 2 radius 2 يبقى instead of R1 2R2 instead of R1 2R2 instead of R1 but 2R2 power 2 low R2 square R1 square sorry R1 square over R2 square. R2 square cancel مع R2 square. L1 cancel مع L1. 2 power 2 equal 4. 4 times 2 equal 8. This is the result. يبقى ratio R2 to R1 equal 8 to 1. Thanks. Wire of resistance 6 ohm R1 6 ohm R1 6 ohm was drawn, reshaped, bent. This I talk about the same wire until its length become 3 times as much as its original length. L2 3 times from L1. Calculate the resistance of the longer wire. You need R2. But the problem don't talk about area. Length 2 equal 3 L1. طب area 2 تبقى equal third area 1 or area equal 3 area 1 تبقى 2 و 2 تبقى 1. اوكي يبقى R1 over R2 equal rho E1 over rho E2 time L1 over L2 time area 2 over area 1. Resistance was drawn I talk about the same wire, same material. So resistivity same. Cancel each other. R1 6, R2, I need R2 equal L1 over L2 3 L1 time A2 over A1 3 A2. A2 cancel مع A2, L1 cancel with L1. So 3 times 3 equal 9. هنا cancel فوق خالص يا ولاد, هيبقى 1 over 3 times 3 9. يبقى R2 time 1 equal 6 time 9, تبقى R2 equal 54 ohm. 6 time 9 54 ohm. Okay. The last law in this session, R equal rho E L square over volume. How? R equal rho E L over area. When I multiply this law by L over L, يبقى ال R equal rho E L, L time L, L power 2 divide area time L equal volume. يبقى ال R equal rho E L power 2 over volume. Or multiply this law by area time area. يبقى rho E volume, L time area, rho V E volume over area power 2. Like that. Okay. R equal rho E L over A time area over area. Length time area, remove length area and put volume. يبقى ال R equal rho E volume divide area time area power 2. يبقى شباب أنا بحط بدل اللينس instead of length or instead of area volume, والother بعمله power 2. Okay. This law is very important to solve the problems. اللي هو rho E L square over volume or rho E volume over area square. Example, cube of side length 10 centimeter reshaped to resistance of reshaped to wire of resistance 20 ohm and its resistivity 10 of power negative 7 ohm meter. Find length of wire and its radius. Okay. wire اللينس بتاعه 10 سنتيمتر, length 10 centimeter. We can get the volume of the cube. Side length 10 centimeter, cube, the volume of cube equal side length power 3. 10 time 10 of power negative 2 to change from centimeter to meter power 3 equal 10 of power negative 3. Okay, meter cube. reshaped يعني يا شباب انا ما غيرتش الواير. reshaped يعني انا عملت من نفس الواير same واير كيوب وبقى واير. الكيوب فكيته بقى واير. الريزيستنس بتاعت الواير مديهاني R. resistivity given rho E. find the length and radius. find the length يبقى هنستخدم R equal rho E L power 2 over volume. rho E 10 of power negative 7. 10 of power negative 7. L power 2 دي أنا I need it. Volume 10 of power negative 3. Resistance equal 20. Equal 20. 20 times 10 of power negative 3 divide 10 of power negative 7 get length. And from the length I can calculate the radius because the volume equal area time length or pi r square by r square time length. By 22 over 7 or by calculator عادي. Length I get it. Volume 10 of power negative 3. So we can calculate the radius. Thanks and goodbye.